Welcome to our deep dive. As a number theory student, you're probably already pretty familiar with prime numbers, those building blocks of integers. But today we're going to be talking about something a little bit different.
Yeah, almost prime numbers.
Yeah, exactly. Almost
However,
prime number.
it's kind of a step up in complexity
Yeah.
from primes and semiprimes, which I'm sure you've come across before.
Yeah, so to get started, maybe you could tell us how we would formally define an almost prime number.
Well, an almost prime number, or almost prime number to be more precise,
Okay.
is a natural number that
Okay.
has exactly k prime factors, and we're counting multiplicity here.
Okay, so for example, a prime number, like 7,
Yeah,
would be considered a 1 almost prime because it only has one prime factor.
exactly.
Okay.
7 is 1 times 7, that's one prime factor.
Got it.
And a semi-prime number like 10 would be a 2 almost prime, because it has two prime factors, 2 times 5.
Makes sense. So in our source material, we have a table here showing examples of almost prime numbers for k equals 3. The smallest example is 12, which is 2 times 2 times 3.
Right, and then if you go up to k equals 4, the smallest one there is 16, which is 2 times 2 times 2 times 2.
Yeah, it gets more complex as k increases.
Exactly. As k increases, the numbers get bigger and more complicated to factor.
Right, and this kind of reminds me of the omega function,
Oh, yes. Good
which
call.
counts the total number of prime factors in
Yeah.
the number.
That's right.
So is there any connection between the omega function and almost prime numbers?
Oh, absolutely.
Okay,
The omega function actually tells you what k is.
right.
If omega of n is 3,
Okay,
then n is a 3 almost prime number.
makes perfect
So
sense.
it all ties together very neatly.
Now, the source mentions some interesting properties that are specific to almost prime numbers.
Yeah.
One of these that I found really interesting was the product property.
Okay. Yeah.
So can you maybe elaborate a little bit on what that is?
Well, the product property basically states that if you multiply a k1 almost prime by a k2 almost prime,
Okay,
you get a k1 plus k2 almost prime.
okay, I see.
So it's like you're adding the number of prime factors together.
Yeah, so like if we multiply 6, which is a 2 almost prime,
Right.
by 10, which is also a 2 almost prime,
Yes.
we would get 60, which is a 4 almost prime.
Exactly. 2 plus 2 equals 4.
Yeah, it's just like adding building blocks.
Yeah, you can think of it like that each prime factor is like a building block, and when you multiply the numbers together,
Yeah.
you're just combining the building blocks.
Makes sense. And then the source also mentions something called the factor property.
Yeah.
Can you tell me a little bit more about that one?
Sure. The factor property basically says that a almost prime number
Okay,
can't have an in almost prime as a factor if n is bigger than k.
okay.
So, for example, a 3 almost prime number can never have a 5 almost prime as a factor
Okay.
because 3 is less than 5.
So it's kind of like you can't fit a bigger number of building blocks into a smaller number of building blocks.
Yeah, exactly. It's like trying to fit a square peg in a round hole. It just doesn't work.
Okay, so now that we've kind of gone over the definition and some of the basic properties, I'm kind of curious about how we actually go about counting these almost prime numbers.
Yeah, that's a great question.
So the source introduces this function called pick.
Yeah.
What is that all about?
So pick.
Okay.
It's a function that counts the number of positive integers less than or equal to n
Okay.
that have exactly k prime divisors.
Okay, so for example, if we wanted to know how many 2 almost primes or semi-primes
Right.
exist between 1 and 100, we would use pi 200.
Exactly. That would tell you exactly how many semiprimes are between 1 and 100.
Got it.
And the cool thing is that mathematicians have actually come up with a formula
Oh, wow.
for this function, or at least an approximation.
Okay.
It's called an asymptotic formula.
Asymptotic formula.
Yeah, it's a bit complicated.
Okay.
But basically it means that as n gets really, really big,
Okay.
the formula gets closer and closer to the actual value of pick.
So it's a way to kind of estimate the distribution of almost primes as we go further out on the number line.
Exactly. It gives you a sense of how common these numbers are.
Now, our source also mentions the Hardy-Ramanujan theorem.
Oh, yeah.
I know that's like a big deal in number theory.
It is.
But how does it relate to our discussion on almost prime numbers?
Well, the Hardy-Ramanujan theorem itself doesn't specifically deal with almost primes.
Okay.
But it does talk about the number of distinct prime factors a number has.
Uh-huh.
And the way we count prime factors in both cases
Okay.
is very similar.
So by understanding how the number of prime factors behaves in general,
Right.
we can gain some insights into the specific case of almost prime numbers.
Exactly. It's all about understanding the bigger picture of prime factorization.
Yeah, and then the source also briefly mentions something called Landau's result.
Uh-huh.
What's the significance of that connection?
So Landau's result deals with the distribution of numbers
Mhm.
that have a specific number of prime factors,
Okay.
which is exactly what we're talking about with almost primes.
Right.
And so his work actually gives us another way to study how these almost primes
Yeah.
are distributed amongst all the natural numbers.
So it's kind of like we're looking at these almost prime numbers through a different lens now
Yeah, you can think of it like that.
and seeing how they fit into the broader landscape of number theory.
Exactly.
It's pretty fascinating how these different areas of number theory start to connect when we're looking at almost prime numbers.
Right. It's like they're all part of this big interconnected web.
Yeah, so as a number theory student myself, I'm curious, why should I care about almost prime numbers?
Yeah, that's a good question.
Are they just kind of a mathematical curiosity, or do they have broader implications?
That's a great question.
Yeah.
And while you might not see almost prime numbers popping up in like everyday applications,
Uh-huh.
the ideas and the techniques that we use to study them,
Yeah.
they actually have a lot of important uses in other areas. Like, for example, in cryptography.
Okay, cryptography.
The security of a lot of online systems
Right.
relies on the difficulty of factoring large numbers.
Okay.
And, semiprimes, which are two almost primes,
Yeah.
are particularly difficult to factor.
So like the RSA algorithm,
Exactly.
which is used for secure communication.
Yes.
It relies on the fact that it's hard to break down a semiprime into its two prime factors.
Exactly. That's the whole basis of its security.
Wow, so it sounds like the study of almost prime numbers can actually help us understand and improve the security of our online communications.
Absolutely.
That's pretty cool.
It's one of the many ways that number theory has a real impact on our lives.
It's amazing how something that seems so abstract
Right.
can have such a profound impact on practical applications.
Exactly.
That's really fascinating.
It is, and it's just one example of how number theory is full of surprises.
So it sounds like there's a lot more to explore with almost prime numbers.
Oh yeah, this is just the tip of the iceberg.
Yeah, we've only scratched the surface today.
There's a whole world of fascinating mathematics out there waiting to be discovered.
Well, I'm excited to dive deeper.
Yeah, me too. Yeah, it kind of gives you a way to visualize how these almost primes are spread out among all the natural numbers.
Interesting. Now, the source also mentions the Hardy-Ramanujan theorem.
Oh yeah, that one.
I know that's a pretty fundamental concept in number theory, but how does it connect to what we're talking about here with almost prime numbers?
Well, it's true that the Hardy-Ramanujan theorem doesn't directly deal with almost primes.
Okay.
But it does look at the number of distinct prime factors a number has.
Uh-huh.
And the way we count those prime factors in both concepts.
Yeah.
It's really similar.
So by kind of understanding how those prime factors behave in general,
Right.
we can get a better sense of how they work in the specific case of almost prime numbers.
Exactly. It's all about getting that big picture view of prime factorization.
Right. And then the source also just briefly mentions something called Landau's result.
Yeah.
What is the significance of that connection?
Well, Landau's result looks at how numbers with a certain number of prime factors are distributed.
Okay.
Which is exactly what we're talking about with almost primes, right?
Right, yeah.
And his work actually gives us another way to think about how these almost primes
Yeah.
are spread out among all the natural numbers.
So it's almost like we're looking at these almost prime numbers through a new lens.
Exactly.
And seeing how they fit into this broader picture of number theory.
That's a good way to put it. Yeah.
That's pretty fascinating how these different ideas in number theory all seem to connect when we start talking about almost prime numbers.
Yeah, it really is. It's like they're all pieces of this big puzzle.
So as a number theory student myself, I'm curious, why should I even care about these almost prime numbers?
That's a great question.
Are they just kind of a mathematical curiosity, or do they have any real-world applications?
Well, you might not see almost primes popping up in your daily life.
Right.
But the ideas and techniques that we use to study them,
Yeah.
they actually have a lot of important uses in other fields.
Okay.
For example, cryptography.
Cryptography?
A lot of online security systems.
Uh-huh.
They rely on how hard it is to factor really big numbers.
Okay.
And semiprimes, which are two almost primes.
Right.
They're super difficult to factor.
So like the RSA algorithm,
Yeah, exactly.
which is used for secure communication.
That's right.
It relies on the fact that it's hard to break a semiprime down into its two prime factors.
Precisely. The whole security of the system depends on that.
That's amazing. So it sounds like studying almost primes can actually help us understand and improve the security of our online communication.
Absolutely. It's one of the many ways that number theory has a real impact on our lives.
That's pretty cool.
It is. It's pretty neat how something that seems so abstract
Yeah,
and have such a huge impact on practical things.
it really is fascinating.
Yeah, it is. And that's just one example. Number theory is full of surprises.
So it sounds like there's a lot more to explore with almost prime numbers.
Oh, for sure. We've barely scratched the surface here.
Yeah, we've only just started to dive in.
There's a whole world of amazing math out there just waiting to be discovered.
It's pretty amazing how almost prime numbers connect so many different parts of number theory.
Yeah, it's like they're this bridge between all these different concepts.
Yeah, so just to kind of recap what we talked about today,
Uh-huh.
we started by defining almost prime numbers.
Right.
These numbers that are classified by how many prime factors they have
That's right.
and how the omega function gives us that k value
Yeah, exactly.
for a kind almost prime number.
Yep.
And then we looked at two of the main properties of almost prime numbers.
Right, the product property and the factor property.
Exactly.
Yeah, the product property, which tells us that when you multiply two almost primes, you get another one.
Right, and the factor property, which shows us which kinds of factors an almost prime number can't have.
Yeah, like you can't fit a bigger set of building blocks into a smaller one.
Exactly. And we also talked about how mathematicians count these almost prime numbers using that special function.
Right, pick. Yeah,
which
pick.
tells us how many almost primes there are up to a certain number.
Exactly. And that asymptotic formula gives us a way to understand how they're distributed as we look at bigger and bigger numbers.
Yep, it's a pretty powerful tool.
Yeah. And then we connected almost prime numbers to some other big ideas in number theory, like the Hardy-Ramanujan theorem and Landau's result.
Right, showing how all these different concepts are kind of intertwined.
Exactly. And for all of our number theory students out there, we emphasized why diving into this world of almost primes is actually really important.
Yeah, it's not just some abstract theoretical thing.
Right. It helps us understand prime factorization better, which has a ton of practical applications like in cryptography. Yeah, exactly. Like how the security of online systems often relies on the difficulty of factoring those big numbers.
Especially semiprimes.
Exactly.
So basically, by getting a handle on almost prime numbers, you're not only expanding your knowledge of number theory,
Right.
you're also getting insights into the fundamental principles behind some really important real-world applications.
That's a great way to sum it up.
So we've covered a lot of ground today in our deep dive, but I hope we've sparked your curiosity and given you a better understanding of almost prime numbers.
Yeah, me too. Hopefully this has inspired you to keep exploring this really cool area of number theory.
And who knows what kind of new connections and discoveries you might make along the way.
Exactly. There's so much more out there to learn.
So keep those mathematical gears turning.
Right.
And remember, the world of numbers is full of wonders, just waiting to be discovered.
Absolutely.